Good morning. I thought I would make a recording to go over some of the things that we would have done in class today, but also to just kind of organize you for the rest of the week. Excuse me. So you are reading the rest of chapter 6 this week, and we're finishing chapter 6 this week. Just to kind of preview, chapter 7 and lab 7 are kind of the same thing. So we're going to use chapter 7 as a resource for lab. It's all just identifying the bones. And then chapter 8 is joints. So we'll come back to joints and movement next week. All right, so today we would have been discussing bone growth and fractures and abnormalities, and then tomorrow we're going to finish it up with homeostasis. So we're still in chapter 6. Um, I I still want to discuss this and get any questions for that. So that's the purpose of today. So let's go ahead and get started. We had started, oops, you guys talking about bone growth in your in this shared slides, and I noticed that a couple of us didn't finish. So that is going to be on the list, which I'll bring back at the end of this little video. But you want to finish up that slide of bone growth just to kind of give you another perspective of that content. So let's go over the three types of bone growth here. We have appositional growth, endochondral ossification, and intramembranous ossification. Ossification is just another word for growth. And when we talk about bone growth, we want to talk about it in terms of, what's happening overall, but also the cells that are involved in this type of bone growth and, where it's happening. So I'm going to talk about each of those things within each type. So appositional growth overall, this is when you are widening the bone. Okay. So you're either widening or narrowing, or you're maintaining. So it's that kind of diameter change that we're talking about. And this is when, if you remember the types of cells that we talked about, osteogenic cells are the stem cells. So they will differentiate into osteoblasts, and osteoblasts are going to be adding. So I think we had a big plus next to osteoblasts because they are going to be adding bone matrix. The trapped osteoblasts then become osteocytes. So if you remember your osteon, the structure of the osteon, and we're going to talk about the structure of osteon again in lab, those concentric circles, they have those little spider-like things in there, and those are the osteocytes, which are trapped in these pockets called lacuna. Oh, here's the osteon. Okay, so you can see the concentric circles here. It kind of looks like a bullseye, and those little pink guys, those are, I don't know where there it is. Okay, I was like, I don't know where my arrow is. These guys right here, these are the osteocytes trapped in those lacuna. So again, appositional growth is going to work with diameter. And here you can see kind of how that works at different stages. An infant, you're really taking the cartilage model as a fetus and infant. You're taking that cartilage model and turning it into compact bone. So there's a lot of different kinds of growth that are happening here. As a child, the bone matrix is removed kind of in this interior here, and then you have bone deposition occurring on the outer areas. Okay, and then as an adult, you have this bone growth still maintaining, but there are different factors that can actually affect whether or not your diameter is maintained or decreasing or increasing. This just talks about the periosteum, which is the outermost layer of the compact bone. So it's kind of pulled back here. And there's two layers, a fibrous outer and a cellular inner. And this just kind of isolates the bone from any of the connective tissue that's surrounding it. It's also a route for the blood and nerve supply, because we know that bone is a living tissue and it has a blood and nerve supply. but it also actively participates in this kind of bone growth and repair. The perforating fibers, which you can see right here, those allow for attachment of that periosteum. Then endosteum is the inner layer here. It's surrounding the medullary cavity, which is where the marrow is. This is active during bone growth and remodeling and repair. You will see that there's a spongy bone kind of on the inside of that medullary cavity as well, and the endosteum is covering that spongy bone. And here are the type of cells are osteoclasts, and osteoclasts are breaking down the bone. And then you also have osteoblasts that are building it up. The next type of growth is endochondral ossification. So this is when we're talking about the initial skeleton in an embryo, and it's mostly cartilage. So that chondra actually refers to cartilage. Anytime you see chondra, think cartilage. So it's going to use cartilage as a model, and then the bone is going to grow in two directions. It's going to grow in diameter, very similar to appositional, but it's also going to grow in length, and that makes sense since you're not the same size as you were when you were an embryo. So we're just going to go through the steps here, and this is in your textbook, but I don't have a page because I don't have a book with me. Cartilage model is going to enlarge. So the chondrocytes near the shaft. So here's our long bone example here. So the chondrocytes here are going to start to enlarge and disintegrate, leaving cavities. You're then going to have blood vessels that grow around the edge. Okay. And these are going to involve osteoblasts. Osteoblasts are going to form these superficial layers of bones. So here you can see on the outer surface here, excuse me, the osteoblasts forming bone. And we haven't talked about this yet because nobody's hit it in lab, but the parts of the long bone, the medullary cavity is the middle cavity that forms. So that eventually will form here. The diaphysis is the long shaft part in the middle, and the epiphyses, plural, epiphysis singular, are the two ends. Then you have those blood vessels starting to penetrate, okay, and enter that center medullary cavity. That is going to bring in fibroblasts, which are going to help to differentiate into osteoblasts. And then you'll have this primary ossification center, which is where you have spongy bones starting to form. You can kind of see it looks like a sponge here. And that's going to spread towards both ends of bone. You're going to continue to grow by remodeling the what's in the picture here. It's blue, which is the hyaline cartilage, and then what's not blue is the remodeled bone. So the osseous tissue is going to thicken. The cartilage near the ends are eventually going to be replaced by the shaft that's growing in length and diameter. Then you have the capillaries. So now you have vascularization that's going to start to migrate in and start to provide nutrients to all sorts of areas. Now we know cartilage is not well vascularized and bone is. So this is the point at which those capillaries start to come in and create these secondary ossification centers, which are at the tips, at the epiphyses. Oh, metaphysis is the middle. Think middle between the epiphysis, and diaphysis. You don't want to say that too fast. Then these ends start to fill with spongy bone, as you can see here. The articular cartilage is going to remain because there's going to be a joint with another bone. So long bones typically have joints. And so we need cartilage to help kind of cushion that joint. There is a part right here, the epiphyseal plate. Okay, that's going to separate the epiphysis, which is the ends from the diaphysis. And at that epiphyseal plate, you have these chondrocytes, which are producing more cartilage. And then they they produce more cartilage at the epiphyseal end, and then at the diaphyseal end, they're starting to degenerate. Okay, and this pushes the epiphyses away, so that's going to help elongate the bone. And at puberty, you have a lot of growth hormone that helps to stimulate this bone growth, and specifically at the epiphyseal plate. That's kind of how the bone grows. Eventually, what happens is that cartilage is completely replaced, but you do have a remnant. So as an adult, you have this epiphyseal line, which is where your bones were growing during infancy and as a child and at puberty. And this is kind of how the osteoblasts produce the bone faster than the chondrocytes. And so eventually that kind of takes over until it disappears. The third type of growth is intramembranous ossification, and this is going to occur just in certain bones. So we talked about appositional and endochondral kind of occurring in the long bones. This is going to be in more flatter bones, like the bones of the skull and the jaw. Okay, this is going to begin when a specific type of cell called mesenchymal cells differentiate into osteoblasts within embryonic or fibrous connective tissue. So it's normally in the deeper layers of the dermis here. And here you can see the mesenchymal cells, okay? And then you can also see the bone in the middle here. So this is gonna form like a spongy bone. And here's the steps of intramembranous. And again, it's in the flatter bones, the ones that don't have that diaphysis epiphysis structure. So what you're going to see, and I know this is really small, so you might want to jump to your book here, is these mesenchymal cells are going to cluster and differentiate into osteoblasts. Osteoblasts are building cells, B for building. We want to remember the plus. So this is going to add matrix. That matrix is going to become mineralized, and this is going to be called the ossification center. And here down below, you can see an ossification center on the left. Oh no, this one's bigger. So then the bone grows out into small struts called spicules. You can see some spicules kind of here. I don't know about the word struts, but if you can kind of think of those ossification centers kind of jutting out, okay, that's what's happening. The osteoblasts become trapped into pockets and they then mature into osteocytes. The mesenchymal cells, continue to produce more osteoblasts or differentiate into more osteoblasts. And then you have your vascularization occurring. So your bone spicules are going to meet and trap blood vessels. And here you can see the spicules kind of jetting out and meeting. Here you can see they've kind of fused and they've trapped some of the vascularization. And then you have continued deposition of bone, which close up the blood vessels completely. And then you have some spongy bone that's interwoven between compact bones. So this is the structure of a flat bone. It doesn't have that nice cavity in it like some of the longer bones. But that doesn't mean that this spongy bone doesn't have marrow in it. There is marrow in this area as well. Remodeling then produces osteons and that compact bone that I just discussed. So it's important that you see that intramembranous ossification is going to produce some of the bones of the skull here. And you can see that at 10 weeks. So then at 16 weeks, you can identify most of these bones. And so then you have the endochondral ossification really taking over where you have the lengthening of bones. There is a video here in the in the slides if you want to look at that. Make sure though you are using the book. I do want to stress that the textbook is very good with its pictures and its descriptions, and it's not too wordy. Going along with growth, I want to talk about fracture and then um, some of the abnormalities that involve growth, like osteoporosis. And so that'll kind of wrap up today. All right, so steps in fracture repair. Step one, okay, so if you've broken your bone, right, any bone, you're going to have a hematoma that forms. A hematoma is this area that kind of swells, and you've got all of this blood cells, red blood cells and white blood cells that are rushing to that area. So that is a large clot, and it kind of closes up the injured vessels, and it develops within several hours after the initial injury. Step two, you have a callus formed. And so this is step two right here. The internal callus is the spongy bone, okay? And it's going to take care of the inner edges of the fracture, and the external callus is on external, obviously, but it's composed of both cartilage and bone, and it's gonna stabilize the outer edges. You then have spongy bone formation. So that's the cartilage of the external callus. It's going to be replaced by spongy bone, and bone fragments and dead bone are going to be removed by those immune cells. And then the ends of the fracture are kind of firmly held in place. And then you have compact bone formation, and you'll have this external callus that sort of leaves a bump on the bone. Remodeling will eliminate that bump, especially the younger that you are, although there is evidence of fractures. You can usually tell a bone has been fractured. Types of fractures, closed or simple, open or compound. You've probably heard these things before. Closed is completely internal. There's no break in the skin. A compound is broken through the skin, and it's more dangerous because now it's open to the outside, and so there's infection or bleeding that could occur. You also have types of fractures called transverse. So if transverse is, it's across the axis of the bone, whereas spirals kind of twist or stress of the bone. And so you can kind of see it sort of twisted along the bone. Also have displaced, which there's just an abnormal arrangement of the bones. Oops. And compression, where you see vertebrae kind of having extreme stress. And compressed, that's often with osteoporosis, you see that. Green stick is on one side. Here's a common green stick one. This is very common. It's very common in kids as well because it's a little break and they're, hardcore running, playing, jumping, whatever. And the long bones have yet to ossify, so that's common. And then there's a comminuted fracture, which is a shattering of an area, and this just looks so painful. This is the hip bone over here. This is the femur, and that just looks terrible. I gotta get past that. Epiphyseal fractures. My son is an expert on this one. But when he was 4, he had his epiphyseal. He had a crack in his humerus, and it was an epiphyseal fracture. And then the next week he broke the other arm in his humerus. Ugh. Anyway, and he's had to have his humerus bones monitored because we don't want anything to happen to that epiphyseal plate when it's growing. We want that type of fracture to heal perfectly so it doesn't affect that long bone growth. Other types are Pott's fractures at the ankle. That's going to affect both the lateral and medial malleolus. So the malleolus is the part that sticks out on the tibia and the fibula, and so it's going to affect both the lateral and medial sides. A Colles fracture is in the distal radius Okay, so we're gonna skip to the some of the abnormalities, although this is all vertebral abnormalities. So the reason I want to talk about osteopenia and osteoporosis is because it involves some of those cells we talked about last week. So osteopenia is the ossification has an inadequate amount of osteoblast activity. And so you're going to lose bone mass. And this often occurs between ages 30 and 40. I can attest to this. The last time I had an x ray, they showed some of my bones were osteopenic, meaning that um, it's starting to degenerate. The bone is losing mass. Osteoporosis is when you have, it looks like holy bones, porous bones. Okay. And so that's when you have the osteoclasts osteoclast activity well exceeding osteoblast activity. Over time, you do lose bone mass. It's really important for women to continue with vitamins, calcium. I take calcium every day because of the osteopenia so that we can build up our osteoblast activity and maintain bone mass. Okay, that's all I really wanted to talk about in terms of uh, bones today. Let's see here. I did want to share this slide with you. I do want to make sure you finish those bone growth slides. That's this guy right here that we started in class. You have time, this was a shorter video, to complete chapter 6 practice quiz, which is all about the bones. 2 of you haven't finished the chapter 4-5 practice quiz. Please make sure that gets done. And make sure that you can log on to the Cincy State Blackboard. That's where our final is going to be. Also, as a practice before we get to our final, I'm going to put the next practice quiz on there. So make sure that you get that set up. Tomorrow, we're going to talk about bone homeostasis and some of the other bone abnormalities that kind of jet around with bone homeostasis. So hopefully we'll see you tomorrow and we won't have another one of these days.